the related rates worksheet. In this first problem here, we got a receptacle in the shape of an inverted. You got this picture right here. The height is 10 and the length of the base is 6, square base. So what we're trying to figure out is how fast is the water rising? In other words, find h prime. When it is 2 inches deep. In other words, when h equals 2. Another information that's given is being filled with water at a rate of 0.2 cubic inches per second. So this is the rate of change of the volume. V prime equals 0.2. And I think that's everything that we have off the bat. So you look at this formula and you're like, okay, volume equals the area of the base. So maybe, I don't know, B squared times H divided by 3, where B is the length of one of these sides, or I guess really the length of one of these sides. So this right here is B. Okay, seems like a lot of variables floating around. You got a V, a B, and an H. And in fact, there are. All the information you're given in the problem has to do with V's and H's. It would be nice if there were no B's. In fact, I can get rid of B's if I express V just in terms of H by using similar triangles to express the length of one side of the base, aka B, in terms of H. So the way you do that is if you draw this triangle here, on the big triangle, I have this is 6 and the height is 10. And on these smaller triangles, I have that this is H and this is B. And using similar triangles, I know that, let's see, which way should I do this? I want to get rid of the B's. So I will say B divided by H must be equal to 6 divided by 10. And let's see, I should be careful here. I guess B is the length all the way across. So that's B right there. So what that tells me is that B is equal to 6/10, aka 3/5 of H. So I can go and I can rewrite this formula, except everywhere I see a B, I can change it into 3/5 of H. So that thing's being squared times H divided by 3, which I can simplify. That's 9/25. But when you take 9/25 and you divide it by 3, you just get 3/25. Then I got H squared and another H. That gives me H cubed. Okay, so V equals this. Therefore, V prime is equal to 3/25 is just a constant, times the derivative of H cubed would be 3H squared times H prime. So I got 9/25 from the 3/25 times the 3. And then H squared, well, I figured out up here that H was 2. So times 2 squared times H prime, which I don't know. And that's got to be equal to V prime, which is 0.2. So I can solve for H prime because I got an equation here. I can say that, 0.2 from the left-hand side of the equation is 4 times 9 is 36. So I got that H prime, if I multiply both sides by 25, 25 times 0.2 is 5, and then divide by 36, I get H prime is 5 over 36. And if you care about units, I guess you could figure it out. I think everything was in, centimeters? Inches, I guess? Inches, and these rates are per second. So I guess if you really cared about units, you'd put those in there. I don't, but I'll do it anyways. 5 over 36 would be my answer. All right, this next problem, consider the hyperbola y equals 1 over x. That will serve to be my equation, y equals 1 over x. And think of it as a slide. A particle slides along the hyperbola so that its x-coordinate is increasing at a rate of f of x. So x prime is my f of x. If its y-coordinate is decreasing, so y prime is equal to -1, is decreasing at a constant rate of 1, what is f of x? Well, it turns out this is all the information that I need to solve this problem. If you take the derivative of both sides of the equation, you get y prime equals, you can think about this as x to the -1 power. So if you bring that -1 down in front, you get -1 x to the -2 times x prime. So y prime, which is given to me to be -1, is equal to -1 x which is given somewhere. So this x coordinate is increasing at a rate. Well, I guess it's just x. Negative 1 equals negative 1 x to the negative 2 times x prime. But x prime is f of x. So solve this thing for f of x and you're done. Well, to solve for f of x, I'd multiply both sides by 1 and then multiply both sides by x squared. I will get that f of x must be equal to x squared. Strangely worded problem, but you can do it, and that ends up being the answer right there. All right, finally, this mess here. You got people running around a track. I think the easiest way to do this is using some trig. So two runners are running on circular tracks. They have a circumference of this number. The tracks are 100 feet apart. Turns out that's not relevant at all. The runners start opposite each other. So one starts here, one starts here, and move at the same constant rate of this. How fast are the runners separating when each has run this far? Well, when they've run that far, we'll put them somewhere over here. In fact, it's exactly that. 165 divided by the total of 1320 ends up being 1/8. So if they've run 165 feet, they've made it an eighth of the way around the circle. And so what I'm going to do is draw this little triangle right here. Draw a right triangle. And if they've gone an eighth of the way around the circle, then this is 45 degrees. That'll be important later on. So okay, let's see. What am I trying to figure out here? How fast are the runners separating? So really, all I need to know is x prime. Well, that's not quite the answer, but if I figured out x prime, I'd know how fast this guy's moving in this direction. And twice that, since one's moving in this direction, one's moving the other, would be my answer. So x prime is what I want to figure out. What I'm going to do is call this angle theta. And the reason I want to call that angle theta is because I am told information about how fast theta is changing. So I need to come up with an equation that relates together theta and x. I guess I can do that if I call this r. I could say that the cosine of theta would be equal to adjacent over hypotenuse, x over r. And they don't tell me what r is, but they do tell me that the circumference is 1320. So if you remember that 2 times pi times the radius is equal to 1320, the circumference, you can figure that r is half of this number divided by pi, so 660 over pi. And the radius never changes, that's a constant. So really what my equation boils down to here is that cosine of theta is equal to pi over 660 times x. Instead of 660 over pi, since I'm dividing by r, I'll take the reciprocal and write it here. Take the derivative of both sides. The derivative of cosine is sine. So I get sine of theta times, that's not true, the derivative of cosine is negative sine. Negative sine of theta times theta prime is equal to pi over 660 times x prime. X prime is what I want to figure out, so I could say that x prime is equal to the negative of 660 sine of theta times theta prime divided by pi. So I took this whole thing and moved it over to the other side. That's supposed to be a pi, not an h on the bottom. Okay, problems. What's theta, or what's sine of theta? What's theta prime? Well, I can find sine of theta, because sine of theta is going to be the adjacent, well, you can do this a few different ways. Sine of theta, so this 1/8, so the runner is 1/8 of the way around the track. So what that tells me is that theta must be 45 degrees. If theta is 45 degrees, the sine of theta would be the sine, it's a weird way to write that, find sine of theta. Well, theta is 45 degrees. Sine of 45 degrees is equal to root 2 over 2. So I know what goes in here. What about theta prime? Well, let's see. Each move at the constant rate of 880 feet per minute. So if they're going 880 feet per minute, maybe I'll write this up here. So they're doing 880 of the 1320 per minute. So 880 of the 1320, I bet that reduces really nicely. Let's see, that's 88 over 132, which I think you can divide by, what, 8? And that gives you 11 over 10, 14. Is that right? 14 times 8 is 132. 8 times 4 is 32. That's not true. Divide these by 11. That's how this works. So this ends up being 8, and 11 goes into 132 12 times, and 8 twelfths is 2/3. So what this is telling me is that the runner does 2/3 of a lap per minute. In other words, 2/3, so maybe theta prime is equal to 2/3 of a lap, 2 pi per minute. In other words, theta prime is 4 pi over 3. So I can take all that information and plug it in here, and I get that x prime, which is what I was trying to figure out, is negative 660 times root 2 over 2 times theta prime, which I figured out was 4 pi over 3, divided by pi for this pi down here. The pi's cancel out. This 2 and this 3 makes 6, which cancels out with part of this. I get x prime is equal to negative 440. That's the 6 and the 660 net out to negative 110, which times 4 gives me 440. The pi's cancel out, square root of 2. So x prime is equal to negative 440. Let me write that a little neater. Negative 440 square root of 2. That's not the answer. That's telling you the rate of change of x. X is getting smaller at this rate. But if x is getting smaller, then you can kind of think about the distance from the middle to the runner as increasing at this rate. And since there's a runner on this side where that distance is increasing and a runner on this side where that distance is increasing, I would say the answer is twice that. Maybe so answer is 880 square root of 2. That's the answer. I guess I should be careful with my units. 880 square root of 2 is in feet, and that is per minute. Because everything in this problem was in feet and minutes. And so I think that's good, and I'll call that good and end this video here.